f of x is called the primitive of f of x, and c is any arbitrary constant called the constant of integration. N cannot be equal to -1 because why? If n is equal to -1, denominator becomes 0. So this is possible for n not equal to -1. You can keep all the constant outside the integrals and you can differentiate each function separately and write the antiderivatives. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in today's session, we are starting up with the new chapter, Indefinite Integrals. So in this session, we are going to study about the antiderivatives, which is nothing but the integrals, and also evaluation of some standard integrals. So what do you mean by this antiderivatives or integrals? Antiderivatives or integrals or the values when you integrate it. So it has to be done with the process called integration. So integration is the inverse, reverse or opposite process of differentiation. Actually, differentiation is nothing but dividing the function into parts. Integration means making it as a one complete function. So here we have basically two types of integrals. One is indefinite integrals and definite integral. Indefinite integral deals with the value where you are going to find out the antiderivative of a given function, and definite integrals are used to find the area of the unknown curves. So in this chapter, you will learn purely about indefinite integrals. Now, as I said, integration is a process of or an inverse process of differentiation. We call the values as the antiderivatives or integrals of the function. So it is also called as primitive of a function. So a function f of x, usually differentiation is denoted by small f of x, integration is denoted by capital F of x. So a function f of x is called primitive or antiderivative or an integral of a given function f of x if dy by dx of f of x is f of x. That means antiderivative of the function is called f of x. As you have learned log and antilog. The log value, so if you put antilog for that value, you will get the original value. Like that, this is called as antiderivative. So here is an example I have taken. X square by 2 is primitive or antiderivative of x. Because if you differentiate x square by 2, it is x again. So we can write integration of x square by 2 is equal to x. So this we write using the symbol x square by 2 dx, that is equal to x. So when you integrate, this is called as the integration symbol. So this is called as integrand. The function which are going to integrate is called as integral, and we are integrating with respect to x here. So the variable here is x. So therefore, the integration of x square by 2 is x. Similarly, sin x is the antiderivative of cos x. If you derive cos x, you will get minus sin x. So therefore, the antiderivative of sin x will be cos x. For example, if you differentiate sin x, you will get cos x. So therefore, the antiderivative of cos x can also be minus sin x. Next we have log x is primitive of 1 by x. So we usually derive 1 by x. If log x is given, it is nothing but 1 by x. So antiderivative of 1 by x is nothing but log x. Why? Because if you differentiate log x, you will get the value as 1 by x. So it is purely reverse process. Differentiate log, you will get 1 by x. Integrate 1 by x, you will get log x. That is why integration is called as the inverse process of differentiation, and the values are called as antiderivatives or integrals or primitive of the given functions. Now, one more important thing you should know that, as I said, x square by 2 plus c, where c is some constant. If you integrate or if you differentiate it, you will get the value as x. That means, in the previous example, I said x square by 2 is a primitive of x. That means when you differentiate x square by 2, say therefore antiderivative of x is x square by 2. Now I have taken x square by 2 plus c is also one more antiderivative for x, because when you differentiate that function also x. So what does the integration says? Integration has infinite number of antiderivatives. So therefore, to represent that infinite number of antiderivatives, we write plus c, which is a constant for the given function. So when you integrate any function, we will add plus c as a constant to show the family of antiderivatives. So similarly, I have taken sin x plus c. I said c is a constant. So when you differentiate sin x, it is cos x. C is 0. So therefore, we can say sin x as the primitive of cos x. Similarly, here log x as the primitive of 1 by x. So therefore, differentiate it, when you get it is 1 by x. So therefore, from the above examples, what we can understand, for a given function, you cannot have a unique antiderivatives. So you have number of antiderivatives which gives back to the function. So therefore, the family of antiderivatives of a given function is represented with the help of a constant c. Now coming to the definition of an integral. Exactly, that is indefinite integral. Let f of x be a function, then the family of all primitives or antiderivatives, or it is called as indefinite integral, and it is denoted by integration of f of x dx. As I said, this is the integration symbol we use. So we write like this. F of x is called as integrand, x is the variable, and we are integrating this with respect to x. Now, d by dx of f of x plus c is nothing but f of x, that is derivative of the function is nothing but the f of x, or integration of f of x is nothing but capital F of x plus c. Why? Because the solution may have infinite number of antiderivatives, therefore the family of all antiderivatives can be represented with the help of the constant function. Now, f of x is called the primitive of f of x, and c is any arbitrary constant called the constant of integration. Now, as you have learned some standard results to differentiate a given function, we also have some standard integrals. So, for a given function, you have a antiderivatives. Learn all those antiderivatives. That will be helpful to solve the integral problems. Let's see some of the standard integrals here. Integrals or antiderivative. So here is an example I have taken. First one is x to the power n into dx. That is integration of x power n can be written as x power n plus 1 divided by n plus 1. Where here I can say n cannot be equal to minus 1. Because why? If n is equal to minus 1, denominator becomes 0. So this is possible for n not equal to minus 1. I'll take an example. Let's take integration of x cube dx. So integration of x cube dx means, according to the formula, it must be x to the power n plus 1 divided by n plus 1. So it is x to the power 3 plus 1 by 3 plus 1, which is x power 4 by 4 plus c. So this is the solution. So if you differentiate x power 4 by 4, differentiate this d by dx of x power 4 by 4, you will get it as 4x cube by 4. So 4 get cancelled, you will get back the function. So you can see clearly, when you differentiate this, you will get back x cube as a function. So therefore, it is called as antiderivatives. Now similarly, we have here integration of only dx. So dx is nothing but here 1 into dx. So therefore, integration of only dx can be written as x, because differentiation of x is 1. Similarly, if you have any integration of phi dx, so if you have integration of dx along with some constant, this can be written as 5x plus c, because phi is a constant, keep it outside the integral. So integrate only dx. So you will get x. So it can be written as 5x plus c. Similarly, if you have integration of d theta. So here we are integrating with respect to theta. In that case, you can write this as theta plus c. So here the variable we have taken is theta. That is why integration d theta can be written as theta, dy can be written as y, dp can be written as b. So whatever the variable we take, we'll apply the same rule. Next we have, as I said, integration of 1 by x can be written as log x, because differentiation of log x is 1 by x. E power x is e power x only here. Integration of e power x or differentiation of e power x is e power x itself. Next we have a to the power x, a to the power x log a. Next, integration of sin x is cos x. Don't confuse with differentiation. Differentiation of sin x is cos x. So cos x is minus sin x. But here integration of cos x is sin x. Next we have secant square x is tan x, because differentiation of tan is secant square x. Next, similarly, integration of cosecant square dx can be written as minus cot x plus c. So we can write this as minus cot x plus c. Secant x tan x is secant x, because differentiation of secant x is secant x tan x. Similarly, cosecant cot can be written as minus cosecant x plus c. So these are the some basic standard values you should remember while solving the problems. Next, let us look at some of the properties of indefinite integral. So the property 1 says d by dx of integral of a function is always equal to the function. So it is same. So when you have the function along with the inverse, so that is nothing but the function itself. So here d by dx means you are differentiating the function. So integrating f of x means again you have to integrate. Let us take one example. I'll take d by dx of integral of cos x into dx. Let's write d by dx. What is integral of cos x? We have studied integral of cos x can be written as sin x. So therefore, I'll write this as sin x. Now, what is differentiation of sin x? Differentiation of sin x is cos x. So you will get the same function. So when you have the derivative and integration for the same function, the value is the function itself. Coming to the second property, we have again if d by dx of integration of f of x and d by dx of integration of g of x. That is, suppose if you have two functions f of x and g of x, when you have d by dx on left hand side and right hand side, you can remove the differentiation, you can just integrate the function. Next, property 3 says when you have two functions in the form of sum, that is integration of sin x plus cos x, integration of 1 plus x, like that, you can apply the integration separately for f of x and separately for g of x. Next property, it says if you have any constant along with the function, keep the constant outside the integral, just only integrate the function and write the antiderivative. This property can also be extended for a sum of many function. So if you have k1 f of x, k2 f of x, k3 f of like this, you can keep all the constant outside the integrals and you can differentiate each function separately and write the antiderivatives. Now, since we have studied some of the standard integral, let us take few problems, that is to evaluate the integrals. Here we have evaluate the following integrals. First power is x to the power 5 into dx. Integrate x power 5 dx. This is of the form integration x power n into dx. So what is this? This is x power n plus 1 by n plus 1 plus c. So therefore, what happens for this function? This is x power 5 plus 1 by 5 plus 1 plus c. So therefore, the integral value is x to the power 6 by 6 plus c. Next we have integration of 6 root x dx. So as you look at the properties, when you have any scalar multiples, keep the constant outside the integral. So this can be written as 6 integration of root x dx. So root is nothing but x to the power half into dx. So what happens? Again using the same formula, I can write this as 6 into x to the power half plus 1 divided by half plus 1 into dx. So this becomes half plus 1 is 3 by 2. So 6 x to the power 3 by 2 divided by 3 by 2 into dx. Or I can write this as 6 into 2 by 3 into x to the power 3 by 2. So here you have to write plus c and plus c cancel 2's are. So it is 4 x to the power 3 by 2 plus c. So this is the value of the given integral. Next, we have integration of 1 by 5 e to the power minus x. So I can write this as integration of e power minus x to the numerator divided by 5 dx. Again 1 by 5 outside, integration of e power x dx. What is integration of e power x? It is e power x only. So therefore it is 1 by 5 e power x plus c. Next, 8 divided by cosecant x. I'll write 8 outside. Integration of 1 by cosecant x into dx. So 8 integration of sin x into dx. 1 by cosecant can be written as sin x. So now what is integration of sin x? Integration of sin x is minus cos x plus c. So it is minus cos x. So therefore it is minus 8 cos x plus c, because we have 8 as a multiples of integration. Next we have integration of 9 divided by sin square x dx. So this can be written as 9 into 1 by sin square x dx. So 9, 1 by sin square is cosecant square x dx. So we have integration. What is the integration of cosecant square x? It is minus cot x. So therefore the value is minus 9 cot x plus c. Let's look at the next one. We have integration of 2x square minus 3 by x plus 2 e power x dx. As I said, when you have a sum of many functions, you can integrate each one separately. So I'll write this as integration of 2x square into dx minus integration of 3 by x dx plus integration of 2 e power x dx. Since I have all constants right outside, it is 2 into x square dx minus 3 into 1 by x dx plus 2 into e power x dx. So what is integration of x square? It is x to the power 2 plus 1 by 2 plus 1 minus 3. What is integration of 1 by x? It is log x. Next, what is integration of e power x? It is e power x. So here it becomes 2 by 3 x cube minus m log n can be written as log m to the power n. So this can be written as log x cube plus 2 e power x. So this is the integral of the given function. Next, root x minus 1 by x. So let us multiply this. Integral of root x minus root x by x into dx. So here it is integral of root x into dx minus integral of 1 by root x dx. So here root x is nothing but x to the power half plus 1 by half plus 1. Here this is nothing but root x. 1 by root x can be written as x to the power minus half. So this becomes minus x to the power minus half plus 1 minus half plus 1. I can write this as, this becomes 3 by 2, x to the power 3 by 2 by 3 by 2 minus x to the power half divided by half. So here 2 by 3 x to the power 3 by 2 minus 2 x to the power half. So this is the function. So write the integration constant along with the answer. Next, I have e power 5 log x, 3 log 5 to the base x dx. So now I can write this as integration of e log x to the power 5 plus, here we have 5 log 5 x cube into dx. So remember these rules. E power log x will be x and a power log x to base a can also be written as x. So using these rules, we know e and log are inverse to each other, so we will get the function. So I'll get it as x power 5. Next, here we have in the place of a we have 5. So this is a log a, which is nothing but 5 log 5. So I can write the function. So this is x cube into dx. Now if you integrate this, you will get this as x power 6 by 6 plus x power 4 by 4 plus c. So this is the integral value. Next we have 3 to the power x minus 2 to the power x whole square by 3 power x. Let us expand this. So 3 power x whole square plus 2 power x whole square minus 2 into 3 power x into 2 power x whole divided by 3 power x into 2 power x into dx integrated. So next here, so when you divide 3 power x into 2 power x for each one, you will get it as integral 3 power x by 2 power x. Next 2 power x cancels. So you will have 2 power x divided by 3 power x. Next again your cancels. So you are left with minus 2 into dx. So again I can write this as integral of 3 by 2 whole power x plus 2 by 3 whole power x minus 2 into dx. So now we know integration of a power x is a power x divided by log a. So therefore this is 3 by 2 whole power x log 3 by 2. Similarly 2 by 3 whole power x log 2 by 3 minus 2x plus c. So this is the value, because integration of a power x dx can be written as a power x by log a plus c. Next question, 3 e power x plus 5 a power x minus e log a into dx. So write each one separately. 3 e power x dx plus 5 a power x dx minus the integration of e log a dx. Keep the constant outside. E power x dx, 5 a power x dx, e power log, I already said if you have anything in the form of e power log x, it is actually x. So therefore we have e power log a, I can write this as integration of a into dx. So we get a as a constant, we can keep it outside. Here we get 3 into e power x, this is 5 a power x divided by log a. Next a is constant, integration of dx is x plus c. So this is the value of the given function. So to solve the integral problems, you have to learn the standard result. We'll take few more problems in our next session. Until then, keep watching, keep learning and keep exploring. Thank you.